Hello everyone, this is Hruthik Abburi, and the project we are going to go through is the closest pair of points in the subject analysis of algorithm. Furtherly, going into the subject, we're going to compare two algorithms in the problem of closest pair of points, and one amongst those algorithm is divide and conquer algorithm, and another algorithm is brute force algorithm. And here which we are seeing is the report of the project of closest pair of points, in which we have discussed all the needful from problem definition to the conclusion and going further into the code. Here we can see the brute force algorithm's basic code, which we have gone through, and is an algorithm which works fine for the small data sets but becomes slow for large number of points, as we're gonna see in the next code. And in the code we have taken the points from the closest pair of points problem as well, and here are the example points we have taken as inputs to run this program. And this is the minimum distance for the closest pair, a minimum distance of 2.24. And the algorithm we used in the first two codes is the brute force algorithm, and from the third and fourth are the close for the closest pair is the divide and conquer algorithm. And the points which we are using now are the example points and the inputs which we are going to take for the comparison of both the algorithms. And for the second divide and conquer algorithm also, we are taking the same inputs to maintain an identical input array to ensure a fair comparison between both the algorithms. As an example, for the first two algorithms, I have taken and I have shown the outputs for the random inputs, which are identical ones as well. And for the final code also, we have taken the same inputs, but we are showing the pre-compiled version of the code because of the runtime delay and the time taking process of the code. And starting with the planning of the experiment, we have selected the alternate option, which involves taking 10 values from 10,000 to 55,000 with an increment of 5,000. And the number of iterations per input size is also m equal to 10 iterations, which means we are showing the comparison between 10 iterations for each n value, by which we can get 10 differently random arrays and runtime average reports. And here you can see the values of n I've taken in this project are of 10,000 to 55,000 with an increment of 5,000, also with an iteration of 10, which is m value equal to 10. And the output I've got is here. And we have also gotten graphs for speed and inputs as well. And here are the iterations which we have performed to compare, to check the average runtime and individual algorithm time taking process for each n value and the each iteration. And we got average runtime for both the algorithms. As per example, here we can see a brute force of a 345 seconds and divide and conquer 0.522 seconds, and the speed is 662.11. And we have tested all the 10 n values, and we also got a runtime comparison graph as well, as the graph is between the input size and the runtime. And the second graph is the graph between the speed factor and the input size. And here is the final summary of the both the algorithms with the input size, brute force, divide and conquer algorithm, and the speed as well, based on which we got the graphs by which we can compare both the algorithms. Thank you.